Thanks for the nice introduction. Welcome and good morning to my talk about subpatch. It's my hobby project, and it's a multi-repository management and patching tool. The content of my talk for today is I will present the summary and call to action. So that is everything you should take away from this talk today. Then I will do a short introduction about myself. I will present the overview about subpatch, the problems. I will show my learnings into the problem and the requirements, which I came up with a new tool. So this new tool is that I build a subpatch. Then I do a short demo. Then I repeat the summary so it sticks into the head. And then we have a Q&A session. And I also bought cookies. So if you then we can talk and eat something, and you can give me feedback. Okay. Let's do the summary, everything you should take away from this talk. So the code of the tool is in a rough stage. So it's implemented maybe 20%. But what the point is that the design and concept for subpatch is valid. And why it's valid, this is most part of the content of the talk, which I explain my learnings and why I think this is valid. Second thing is feedback is welcome, so please join the matrix room. I think we have currently 5 people in the room, so please join. Or open a GitHub issue, or email me, or just then meet me after the talk outside. Also, please try it out. There's something you can try it now. It's not a set production ready, but the basic usage is possible. Also, if you like, you can start work on the code, submit pull requests, and if you really want it and you have resources, if you're a company and you really want this tool, you can also sponsor me so I can have more time working on it. As I said, it's a hobby project. I have 2 kids, a day job, friends, and so the time hacking on cool stuff is not so much. And if you can sponsor me, I can work more on it. Okay, that's the summary, that's everything for the talk, but let's dive into the details. Short introduction of myself. This is my website. I'm this guy, I'm Stefan Lengfeld. I'm a professional embedded Linux engineer and Android embedded engineer. Main interests, what I do is Linux kernel stuff and board support development, so bootloader, patching, board bring up, but I'm also, which I'm doing in the last years, a lot of Android and ASP platform engineering. So I bring Android on custom devices. I'm also working on the Linux and Android graphics stack. I'm doing general bug hunting, reverse engineering, and also system profiling. So if you know the tool Perfetto, it's a system tracer used in Android. It's a really cool tool for tracing and system profiling, and that is something that I do lately quite often, so get more performance out of systems. And also I like to work on complex build systems and on Git and on release processes. And that is the thing why I saw a space for a new tool, complex build system, complex tooling, complex projects, and I think subpatch is a valuable addition as a tool. And and I also like agile software development. That's about me. But let's go back to subpatch. So now in the third thing, present the website. So I have no slides, I have just the website, so everything you can read up then also on yourself on the website. I go to the home page. So this is subpatch, fearless multi-repository management. Stay relaxed. So if you know Git-submodules and feel a pain, maybe subpatch is a tool that can reduce the pain a bit. That is the goal, at least the goal of subpatch. So a short quick start, we will use that later. So what are the use cases I envision for subpatch? So the first use case is assembling, so the Git-submodules use case or repo use case. It's assembling a monorepository from multiple repositories, pulling multiple Git repositories into your repository. Also, second use case is integrating third-party dependencies into your project as source files. So this is also called rendering. So where you, for example, if you have a C++ application, I've done it in my projects in the past, and you have a simple small dependency, you can, or a bigger dependency, you just grab the source code and integrate that into your CMake build inside your repository. This is also a use case for subpatch. Also, if you want to maintain a local fork of an upstream repository, in the embedded projects where I work, it's often the case that we have to patch existing software. So, for example, we have to patch the Linux kernel, we have to patch not so often the C library, but sometimes backport bug fixes to other software, or to fix libraries or add features in libraries. And this is something we do in an embedded space quite often. And local patching is a bit bad because you have to upstream your changes, but in most cases the first thing you do is patch locally, get your product shipped, and send the patch upstream later. And also subpatch will help you with maintaining these patches locally and forward porting it to new releases. And this is also the goal of subpatch. So maintaining a local fork with a linear path stack of an upstream dependency. Okay, that is the use cases. So what is the concept and design? So subpatch is where I have a clock. Here, okay, here. Subpatch is based on git add. So the files of a subproject are added as normal files to the superproject. This is a design decision I've taken, and I will explain later why, but this is, for example, different to git-submodules. In git-submodules, you only have a reference in your superproject. Or in repo, it's the same, you only have a reference to an upstream project. You have not the files in itself. But for subpatch, the files are added to your superproject as really as files and committed as files. We will see that. These superprojects or subprojects are in most cases, so the dependencies you're pulling into your superproject are in most cases are the Git repositories, or in a later stage could be all tarballs or other S4N repository or S4N Mercurial repositories. Also, design and concept is that the metadata of the subproject, for example, the URL of the upstream repository, is saved in a git-config-style configuration file. I don't like, so I'm not using JSON, I'm not using YAML, I'm using Git, the git-config style, because I know that, and it's a quite good config format. Also, the part about local patching, modifications of the subproject are possible, and subpatch helps maintaining a linear path stack of the modification. In Git-submodules, this is not possible without forking the upstream. In repo, it's the same. Repo is a tool by Google for used in the AOSP project. It's also not possible. And this is possible with subpatch. And important last point, local forking is fine, but the thing is you should be able to rebase your local patches to new upstream versions, and also subpatch should help you with that to integrate new changes from upstream into your local fork. Okay, some parts about the website. The website you see here. Just type subpatch.net in your browser. And on the left side, you see 4 big parts. It's one, explanations, tutorials, how-to guides, and references. These are the 4 big subsections. And I've based the documentation of the so-called the Grand Unified Theory of Documentation. So if you do not know that, here's a link to it. And it's a documentation design where it describes how you should organize your documentation, and I'm sticking to this guide to organize my documentation. So these things are tutorials, how-to guides, explanations, and reference. And if you're learning a new tool, in the first place, you're looking at tutorials that you will guide through and learn the tool, and you have explanations to learn the tool. This is the learning part. And on the other side, you have the usage part. So if you're using subpatch or other tools in your day-to-day life, then you should look at how-to guides and references. And on this system of documentation, I've based my website. So you have here the explanations that is telling the learnings that I had in the past years, the requirements of the new tools, and here I have a page that is comparing subpatch to other tools, for example, Git-submodules, design decisions of the code and benefits, and then you have tutorials. So if you then really want to try out the tool, look at this tutorial, so installation, basic usage. And afterwards, so this section, how-to guides and reference is for now quite small because the project is not really finished. But then on the day-to-day usage, every information should be then here in how-to guides and references. For example, I already have a how-to guide to use subpatch for a project based on Yocto. Yocto is an embedded build system to build Linux distributions for embedded devices, and it also has the multi-repository management problem, and here I described how to use subpatch to use it for that. Okay, now this was the concept of the website, how to navigate it. Then we go back to home. Website and documentation, and we have a matrix room, open a GitHub issue, or you can just email me or then meet me outside of the talk. The code and license, it's a GPL v2 license. I choose that license just because the Linux, the Git and the Linux kernel is also GPL2 license. So and as I said, you can already open pull requests if you like. I would be really happy about that. But the code is in a very rough stage. I have per 10 lines of code, I have 1 to 2 comments, and this is quite a lot. But I have a lot of tests, so the code is working. Okay, then let's dive into why I think subpatch is the right design. So even if it's not finished, it's the right design. And here I have on this page, I've described my learnings, and my journey started now 10 years ago. So 10 years ago, I started to have the multi-repository problem. There I started a job as an embedded system engineer, and I was confronted with Yocto. We used Yocto, and we used the repo tool by Google to assemble the multiple repositories from the so-called Yocto layers. And there I used repo, and I used multiple repositories, and I saw problems and headaches all over the place. And then I started to think about this problem. And I will not go into all the learnings I had, but some I will pick up. So here, as said, in 2015 I was a embedded system developer, and we used the repo tool to maintain our multiple repositories. And we had a lot of problems. So checking out branches of a coworker was a pain because you had branches in multiple repositories, and repo does not have a tool to check out multiple branches from different repositories. Switching between branches was a pain with repo, so switching between stable branches and main branches was kind of a pain. Repo had not support for bisecting errors, so Git has bisect, repo does not. And also making a release and tagging was a pain with repo because you had to tag multiple repositories, assemble so-called manifest files, and so the release process was kind of a very big document with a lot of steps and a lot of commands you have to execute, and a lot of things that can go wrong. And there I started, so this is bad, and I'm a software engineer, I can do it better. So let's start a new tool, write repo better. So I started a project in my spare time. It was called Rep. I tried to be a better version of repo, to use the same design of repo and write a better tool, so all these things that repo does not have, for example, switching branches, should work. I worked on that project for 3 months. In the end, there was 3,000 lines of Python code and 1,000 lines of test. And at that stage, I worked on it, and even with 3,000 lines of code, I was not finished. So this was so much to work on, so much to code. And at that point, I noticed I have the wrong design, because my design was based on repo, and repo is a wrapper around Git. And this will never fly. You are not programming a version control system for Git, so a wrapper which is a version control system for Git. So you should not version control Git repositories as repo kind of does, and as my web tool would do So the learning was here in 2015. The solution of the multi-repository problem is inside a Git repository. So inside a single version control system, the solution is inside there. Then I'm on the wrong track. Let's switch tracks. Then I already knew Git submodules, but also using Git submodules was kind of a challenge because of complexity. But I found out Git subtree and the Git subtree merge strategy. Who has heard of Git subtree? Okay, who has used Git subtree? Oh, I want to talk to you. I learned a bit, say, okay, maybe this is the solution. This is the solution. Maybe I have not write my own tool, but this is the solution. But then I noticed, I tried it out, and the documentation is lacking. So I think it's kind of a README file, hundreds of lines. So it's too short, and there's too many pitfalls and too many options. And so, okay, maybe the solution is that I should write a book, a handbook of applied Git subtree merge. So I just have to document the existing tooling better. And then I worked on it and said, okay, this is the point. So any multi-repository management tooling, the important point is good documentation is very, very important, because the problem in itself is kind of very complex, a lot of moving parts. So you have to need a good documentation. And this website is the learning. I start with good documentation, not with the tool, with good documentation first. But then I also started, so if you are using Git subtree, the command Git subtree, you notice that there are a lot of pitfalls and edge cases that are not really working quite well. That you can not only fix with documentation. So not educating is enough for the user, but you also have a good interface, a good command line interface to the user. And so this was also a learning. Good documentation, good tooling is the key. So you have good documentation and good tooling. Okay, so in 2016, 1 year later, I started to work on a better tooling for Git subtree. So okay, let's fix the documentation and let's fix Git subtree. And I started a tool called Git subtree merge. And now I got it right. So I worked on it for 8 months in my spare time. This was the time before kids, so I had time. So I crunched out 5,000 lines of Python code and 10,000 lines of Python tests. So this was really, very, very good tested, and this was really needed, because then I noticed that the Git subtree merge strategy has a lot of edge cases, because the core part of Git subtree is that you are merging the history of the subproject into the history of your superproject. So the Git commits of the subproject, 10,000 commits, are then pulled into the history of your superproject, and you also have these 10,000 commits into your superproject. And then you can have merges and rebases, and this can create a lot of different states, and so you need a lot of tests and tooling to handle all these cases. And at that point I noticed, so this complexity explodes here. So the problem is that really this merging of history into the superproject does not fly, it's too complex. So then I came up with this learning, so using the right design to minimize the inherent complexity to avoid accidental complexity. Yeah, it's maybe a bit too high worded, but it's just don't really try to have a simple tool, because the multiple repository problem is still complex enough to really strip down the possible things that can go wrong. And this was the learning here. So also here's a part about Garrett and repo. I will not go into detail here. So Garrett is a review system for code, so like GitLab or GitHub, but with a UI that is more 10 years later, 10 years earlier. But some people love it. It's had really nice features, and we had used it in our project, and I used the repo tool again and had all the pains with repo again. I started to write a tool called repo-load to fix some of the problems of repo, and this is not going to fly, But let's skip over to that. And then the last thing I learned is, or already learned before, is that if you want to maintain a local fork, as we do as embedded system engineers, the only sane way to maintain that is to have a linear patch stack. So well-defined patches on top of each other with good descriptions and which are in effect. And then if you can have a new upstream version, for example, of your Linux kernel, then you can reapply the patches and fix up the patches step by step. You don't want to have a big diff from 1,000 lines of code. This is not working. And also this downstream forking with linear patch stack is used since the 80s. So for example, every Linux distribution, for example, also applying some patches on packages in their build steps, for example, in dep and RPM. So having a linear patch stack is the solution to maintain a fork. Okay. So with these learnings, and we go to demo time shortly, I came up with a list of requirements. So what should be so now I have already written 2 tools and I've done that. So now I have the third tool, Git-subpatch, and I wanted to get that right, so I write down a list of requirements. What should my tool have and support? I will not go into all the requirements I listed here, but one of the learnings is now really going into one of the requirements. Is the first requirement: do not interfere with the version control system. So do not be a wrapper around a version control system like repo. So existing workflows like checking out the code, or cloning, or switching branches, or updating, or rebasing, or tagging, or forking a project, or bisecting, git bisect, and releasing should stay the same. So any tool should just keep set tooling that everyone knows, everyone learns, same. So the people using your tools should not learn a new way to how git bisect work. And you should also not need to read-write that. Also, subpatch should not be written in that case that you need to read-write all the tooling. And for example, in repo, when you use repo by Google, cloning is different. Switching branches is different. Updating is different. Rebasing is kind of not existing in repo. Tagging is tagging a lot of repositories in repo. Forking is with repo works kind of. With manifest files, and bisecting is even not supported, and releasing is a pain in repo. This was repo-wise. Repo by Google not adequate. Git-submodules is a lot better, for example. Git-submodules is cloning. Git-submodules is kind of works out of the box, but you need a special command line argument. So you need to teach every developer, every contributor. So if you clone my repository, please also specify the extra argument that you can get download the additional repositories. With subpatch, cloning is the same. No additional arguments. Switching branches with Git-submodules is also a bit different. If you switch branches, you have to take care that also the submodules are updated. So you have an extra step you have to take care on. So this is the point about the extra complexity you're forcing onto your users or contributors with, for example, Git-submodules. And that's why also people don't like Git-submodules, because there you have these edge cases that can go wrong. But for example, tagging with Git-submodules is kind of nice. Just tag the superproject, and if you not need to tag also your subprojects, or then tagging is quite of the same with Git-submodules. But as I said, I want to reduce the complexity with subpatch. Everything which you can do with Git, bisecting, releasing, stays the same. This basic requirement. Okay, R2, requirement 2, yeah, Git-subpatch should support Git as a primary source control management tool. Yeah, Git is used by anyone nowadays. As subprojects, so third-party dependencies you're pulling in, subpatch should support Git, CVS, Mercurial, Subversion, and Tarbots, and . But important point, the requirements are the goal of subpatch. Implemented currently is just Git as subprojects. So yeah, but the goal is really to be as open and as flexible as possible. Okay, so this is really just the goal, so where the project is going to. Okay, and the rest of the requirements is about the local patching feature, so that you can have local patches, and subpatch helps you with maintaining the patches. Does anyone know Quilt? Yes, subpatch will kind of be like Quilt, but for subprojects. Yeah, and these requirements are just for that. Okay, and here I have a page for the other tools. So for example, it's submodules, repo. There's also CAS. CAS is a specialized version, but for Yocto. So Yocto has additional requirements and additional features that is CAS implementing. So CAS is a Yocto-specific tool. REST is also a multi-repository management tool, but with features for the Zephyr real-time operating system. And also, I have noted there Git subtree. Okay, and this page, for example, is here an overview of what are the difference between the tools, and later I also want to add that why all the existing tools do not fulfill all the requirements, and why I had to develop my own tool. Really had to. Yeah, it's a pain every time okay, and there are now a lot of other pages here. So for example, I try to document the design decisions of subpatch, for example, that I use Python 3 or why I use the Git-config and This is for reading up later. And also I started to write a page. What are the benefits if you use Git subpatch? For example, one of the benefits is source code reproducibility by design. So because of you are doing rendering, so pulling in the source code of the dependencies directly into the superproject, you are not depending on an upstream server like a Tarball server for the source code of your build, like for example Yocto does at first, or Build.io does at first. And also, what you are not needing is the so-called atomic cross-repo change requests. So if you're using repo or Git-submodules and you integrate multiple of your own projects and into your repository, and have one patch in one repository, and it depends on a patch in another repository, you have to teach your version control system and your review system, for example, GitHub or Garrett, to merge these two patches only at the same time when both are approved. And this is a feature, I do not know if GitHub does have it, but Garrett has this feature. It's called submit. But yeah, if you have multiple repositories and need to patch in all of the repositories at the same time, because of multi-repositories, you need atomic cross-repo changes. And yeah, with subpatch, you don't need that. Okay, let's do the demo time before we can go to Q&A. Okay, demo time. Then we just start by doing the installation. No, installation is just either with pipx. I've uploaded it to pip, or you can have it as a standalone script, as a standalone Python script. Okay. Let's do the basic usage. Show it a bit. Okay, here's an example repository I've coded, and we are just come on, and clone. Also, we are cloning this example repository. This example repository contains a small C library. It has just one libc file, and this library exposes an add function. This is just a simple C example. And in this project, I want to now add a subproject for adding tests. So I want to test my C library with Google Tests. So first we can start building these. So it's based on CMake. Okay, configured. Then we build. And building is procced, and then we can execute. This is a small command line that is using the C library, and yeah, it's adding the two numbers. Yeah, okay, just a simple example. Okay. Now let's go to adding a subproject. Because we have this in my repository, on this example, you have the file test.cc. Test.cc is using Google Test to test the C library. But yeah, I want to have the dependency directly in my project. So first I make an external repository. If you start to use rendering, so pulling in the source code of external code directly, it's always a good case to have an extra directory where you all pull in all the external code, so you have sent in one place. Then we have the subpatch add command. So we are adding a subproject. This is the URL, a Git repository, and here we have a revision. In this case, the revision is a Git tag, but it could also be a branch or a commit hash in itself. Now the tool is downloading the code. It's downloading the Git repository and taking the source files. And it says, yeah, adding the subproject Google test from URL, and it's done. And now it says the following, this is a command output from subpatch, the following changes are now recorded in the Git index. So we have now 250 files, new files, and we have insertions. And this is already also printed out by Git subpatch, so it could give you also now the options you have, what you can do next. For example, git status. Now you see all the files that are added, and yeah, all the files from the library are added. If you want to see the code that was added, then you can use the normal Git tooling, so git diff staged, and you see that, for example, a C-lang format file is added, and you already see what subpatch is doing. For example, here, subpatch has added a file at the top level of the superproject to record that there's now a subproject. I can also show the file here. I go back to the subpatch, subpatch. Here, this is the file where subpatch is recording that we have now a subproject. One question is, where is the metadata of the subproject stored? So the URL and the branch and the commit ID, and this is inside the subproject. So we go to the folder Google Test. This is the files from the Google Test library, but subpatch has added a hidden file here. It's called .subproject, and in this file we have recorded the metadata. So for example, if you update later, subpatch will pull out the URL and stuff here, and also you can look up what you have integrated here. But also, if you do not want to look into files, there is tooling. So subpatch list gives you all the subprojects in your repository, and there's also subpatch status. And this is printing, here we have one subproject in the folder external Google Test, integrated from that URL, revision, And it also already shows that, you have changes that are staged. So subpatch will advise you now what you do. As also git add has advised you, you can use now git commit to add that, or here it also advises you with git commit to add that now. We do that. External, add gtest. And now I've added the gtest library to. I can also go again to subpatch status. It's a bit shorter. We have no changed files into the subdirectory anymore because we have committed it and we have integrated from that URL and revision and commit ID. Okay. This is also explained. Subpatch list, subpatch status. All right. Now we can enable the tests and compile the tests. So we are adding the tests here. This was so we compile and run the tests. It's taking a bit longer because Google Test is C++ code, and C++ code takes a bit longer to compile. And now we have run the tests, and yeah, tests are green. Our test suite has tested our library. Okay, we need to, we have git diff, we have changes in the CMake file, we commit these changes, add test to CMake. Now, we have integrated the subproject Google test, but what is about updating? 10 minutes left. Okay, what about updating? As I said, we have subpatch status to see your subprojects in your repository, and there's the command subpatch update. And with subpatch update, you specify the path of the subproject, so not the URL with add anymore, and you're adding a new revision. For example, now we want to update to a new Git tag, and I just hit enter. And now it again downloads the Git repository, uses the files of the new tag, and integrates the new files or changes into your superproject, the Git repository. And it also prints the diff now. So we have, previously we had 250 files integrated. Now we have just 62 files touched because we have an update. So not everything in the upstream repository was touched, only parts of it. So we have here just 3,000 additions. We can also now look into that. So I could git diff stat staged, because it's always staged. And this shows now which files upstream, so Google engineers has touched between the latest release or the previous release and now the latest release. So you already have a kind of an insight how much has changed of your upstream project between two releases. Okay, then we make commit external update gtest. Now it's always a good thing to rebuild your project. So maybe your dependency has changed our public API, which should have been stable, but it's anything not. Rebuilding it, re-executing it, and still everything is fine. Nice. Okay, finish the update, and we can also then use subpatch status, and it will print out that we have now integrated the new version, the 17 version. Okay, so this was the part of integrating a project and updating a subproject. But what's about patching? So where does patching come in? And this was the latest edition, and there are a lot of commands left to be really production ready and really be used in production, but the basics are there. So everyone is using quilts, knows quilts, and this will now look quite similar. So we have a subpatch command. So I go into the Google test directory. I have commands subpatch pop, subpatch push, and subpatch apply. With these commands, you can maintain the patch stack. So for example, with the apply command, you can take a patch file from git format patch and apply that to your subproject. So similar to git am, where you take a patch and apply that to your Git repository. And under the hood, it is using exactly the same Git tooling. So I'm not rewriting anything. So I do not want to write a patch applier code myself. I'm just using what Git has. Okay, now I applied the patch. A patch applied at FrOSCon printout. We can shortly have a look into the patch file. This is the patch file. So this is a patch file generated by Git itself. Here we have the subject. There could be also a description, and we have a change log. And here we have the diff. So here I'm just adding 2 new lines saying hi to FrOSCon. So this is the patch file I have applied. And also subpatch is also now telling us what to do, or what has happened. So what has happened, subpatch has changed 2 files, and we have now 27 new insertions. And what we can do now is again call git status or git diff staged to inspect it. So we're doing that. So what has changed? And we see here, okay, subpatch has applied the patch, and we have in the directory external Google tests, the file google test source.gtest was patched. So we have seen that file in the diff of the patch, and this was now applied to our working tree on the Git repository. And what also has happened, this patch file in itself was added now to our Git repository. So I'm recording the patch file inside the subproject. This was the part about maintaining the linear patch stack, and therefore I have to save the patch file. And this can later then be used, for example, either to send it upstream or to rebase it on a new change or a new upstream version. So we have looked at git diff staged. Okay, works. Then we committed external, add my mods, don't care. Okay, everything is added. Okay, we go back. Now we just want to rebuild. Rebuild. Okay, it's C++. Takes a while. Execute it. Where was it here? The test. We have successfully patched our subproject. Here now this line was not before there, so this could also be an addition, a new feature you need into an upstream project, or bug fix you're backporting, and with that you can maintain local forks easily. Okay, now I can also show you pop and push. So if you know quilt, this will be the same. Subpatch status. What we also has changed now is that subpatch status will also report that we have one patch inside the repository. And I call subpatch pop. Now the patch is popped again. So the working directory, the files in the working directory have now changed and the code was removed. I can use git diff staged. And you first see, okay, let's look on that. Here you see that now these two files are removed, two lines are removed again because the reverse of the patch was applied. And here I'm tracking with this in the metadata of the subproject which patch was applied, because I kind of need a way to track which patch was applied. Okay, so I could now commit that, but that would be not good, because in the same state all patches are applied. But that you can use, for example, to drop a patch or to add a patch in between, or And you can now call subpatch push. And this patch is now applied again. Push the patch to the subproject, and we have no changes here. Git diff staged is empty, and git status is empty, and now the patch was applied again, and everything was as the status before. Okay. We have seen the part about adding a subproject as plain text files to your superproject. We have seen updating the subproject, and we also have seen applying local patches. So we actually have seen kind of everything that as I have promised here. So assembling a monorepository, integrating third-party dependencies as source code files, as rendering, and maintaining a local fork and patch stack. And I also explained why I think this design, as my third tool, is actually the right design for maintaining the multiple repository problem. And with that, I'm going to my summary and call to action. So yeah, the code is in a rough stage. Sorry, but I really want to stress the point. I think the design and concept is valid, and that is the way how multi-repository managed should work. Feedback is welcome, so please join the matrix room or open a GitHub issue and email me. Yeah, please try it out. Any feedback, so any feature wish, I will then any feature wish that you have, I will prioritize that. And yeah, if you like, you can start work on the code, but yeah, beware, it's very rough stage. And yeah, and if you really want to have me have it and have the resources, and yeah, maybe you can sponsor me so I can work more on that, not only in my spare time. And with that, I want to end my talk, open up for Q&A, and I have cookies. So everyone who wants to continue talking after the Q&A session can meet me outside, and yeah, then we can also have some cookies, and also my child.
Thank you very much to you, Stefan.
Thanks
for your talk. And now the Q&A is open.
Yeah. Look.
You need a microphone?
Hi, I want to know what happens when I want to integrate a new version of a subproject.
Yes, yeah, subproject.
But I have patches applied. I imagine that the patches will first be popped, then the update is happening, and then pushed again.
Exactly.
And what happens if there are merge errors?
Okay, so very good question, because this is also one of the core features subpatch should have. So yeah, I think called it should rebase local patches automatically when doing an update of a source dependency and there are no conflicts. Then it should happen automatically. And yes, this is a feature I want to have and I want to implement. It's not implemented right now, but exactly that would the process. So we would pop the patches, update the subproject, and then reapply the patches, and then look for changes. And I even envision some kind of, when I maintaining a local fork with Git, so not a subproject, but Git, then I often use git rebase -e for interactive to rebase it. And I really envision kind of the same mode tooling that you can really then use git rebase -e and rebase them and work on that maybe for an hour or a week. Depends on how many conflicts there are, and then reintegrate the new patch stack. But exactly first popping, updating it, applying again, and then if you're finished, you have a new patch stack with a same patch stack. Often it's the case that you need to remove patches. So you have often the workflow that you have a local patch, work on it, ship it in your project, but send it parallel to upstream. Upstream will integrate it, and you have that in the next version. So in the next upgrade, you can pop or remove that patch. Yeah, exactly. Thanks.
Yeah, so my question is, can you also use it to work on subprojects that you manage yourself and make new commits in those subprojects as well while you're using them as subprojects in your superproject?
Yes, you can, but beware that you have now it's your project, so you have the code of your project now in two places. So in your subproject, which is superproject kind of, and the common example is a library. So you have a library that you share between multiple products, and this is so we have two products repositories, which are two superprojects, and there you have a copy with subpatch. There you have a copy. So if you patch in the product repositories, superproject repositories, apply changes there, they are not automatically in the library. They are only in the local fork of the library. So it's not kind of git-submodules where you really need to push first. Yeah. So in that case, you have now 3 copies. Maybe we can. Yeah. Okay.
Yeah. If you add a subproject in your Git repository and then you update it later again, is the entire history of the subproject included in your local Git repository, or only the individual versions, or is it only references?
Okay. No reference. So if it would be reference, that would be git-submodules. If you wanted, that would be good. Would be submodules. In my case, I really use git add. So I'm not having the history of the subproject. If you want that, then you use git subtree merge strategy. That would be pulling in the whole history. But I really, at my learning, I really decided against that approach, because in most cases, the history of the subproject is not really relevant to your history of your superproject, of your normal project. It's just a dependency. You are not really interested in all these small changes that a subproject is doing. It really would pollute the history with a lot of commits that are not relevant to you.
That was what I was worried about. Like if you only update like one in every 5 releases or whatever, you only get those individual big diffs.
Yeah. Here I think I have it. Here it's design decision 6. The subproject's history is not included in the subproject's superproject history because of that. Yeah, and as you said, if you skip some releases of the subproject or the upstream project, only the version that you now integrating will be integrated, not the intermediate versions. Yeah, so you only really get the code that you are really using. Yeah. So also the size increase is moderate. Yeah.
Any other questions?
No, please.
So if you are going to do a bisect with upstream source, the vendor source, how is it going to work? Will it pick every version, edit and remove it again, or jump back and forth?
I didn't get, you asked about git bisect and the usage of
if you are handling a bug in a vendor repository,
yes.
You want to pick that particular change.
If you have a bug in the vendor repository and want to bisect that. Good question. I've not thought about it before. Because you, in that case, subpatch will not help. In that case, you will need to clone the vendor component, so the Git repository of the vendor component, and then integrate that into your build process and then bisect the vendor component in itself. Good question, good feature, but yeah. To be fair, git-submodules also had not that feature. Git-submodule has that feature. Okay, damn it. Okay, you have me. Okay, one feature I've missed. Yeah. Thanks.
Maybe something else. Git export. Can you add a feature to skip some parts explicitly?
Git export? You mean the tarball export? Or?
Yeah, exactly.
If you would, you mean Git archive?
Yeah, exactly.
If you do Git archive, it really works as before. So all the files of the Git repository, also all the files of the subproject are exported as a tarball.
Okay.
Yeah, okay, it would be an advantage to git-submodules, yes. Yeah. Because really all the files that you're using in your build is inside, with subpatch. Yeah.
I have another one, but not
We can also talk outside. Yeah.
Okay. No more questions? No? Then thank you again.
Okay. Thanks for the questions.